Another thing that you should consider when choosing your object detection model for your specific task is how the model performs with respect to the object size. The object size here, we mean that the object that you want to detect in your image. So in that same referenced paper, they have made these experiments here, and they have given us these graphs that tell us a lot about how the neural network will perform when the object size is either small, medium, or large. So here, the blue color here represents the overall mean average precision, and the green one represents the mean average precision of the network when the object that it's trying to detect is large. So you can think of it as a car, for example, on the road. If it's closer to the camera, it will look large, and if it's far from the camera, it will look small. So this is how you think about large and small objects in the image. The orange represents medium-sized, the mean average precision for medium-sized objects, and this pink color represents the mean average precision when we have small objects, so objects that are far from the camera. So here, when we look at this, we can make so many conclusions again. For example, we see that overall, when the objects are large, then faster RCNN works best. It has the best mean average precision. And when the objects are medium, so here the orange colors here, we see again that faster RCNN is still the most accurate one for this size of the objects. And also, when we look at the small objects, so the pink color here, again, we see that faster RCNN is doing very well. And here, this is faster RCNN with ResNet 101 as a backbone, and this is faster RCNN with Inception ResNet v2 as a backbone. So this is also something that you should consider when choosing your neural network, depending on the sizes of the objects that you want to detect. So generally speaking, when we look at the different data sets that exist, the public data sets, we see the same objects in small size and in large size. But depending on your application, maybe you have a fixed camera on that's looking at something specific, and you always know that the thing that you want to detect is small. So in this case, you would go, for example, with faster RCNN if the time is not a constraint. So if you have enough time and you're not looking at real-time object detection, then you would go with faster RCNN because it's the most obvious choice here. So apart from this, we can see that, for example, with SSD here, with large objects, it's still doing very good compared to faster RCNN. And since SSD actually takes less time at the inference than, for example, faster RCNN, this means that if you are looking for a model that needs to make predictions fast, then maybe you would choose to lose some points in terms of mean average precision, but you will gain some points in terms of speed here. So this is another thing that you should consider, and this graph is very helpful in making those decisions.